Assalamu alaikum. Today we are going to start ninth class chemistry. The topic about nomenclature. You have to given a name to the hydrocarbons, but according to IUPAC, International Union of Pure and Applied Chemistry, according to IUPAC system, we have to follow different rules. Let's consider some examples. Okay. For example, we have a compound. First of all, we have to select the longest chain. Okay. When we select the longest chain, then we have to count the carbon atoms, and the numbering of carbon atoms we have to start either from left, either from right, but we have to consider about the substitute where it is closer. Okay, if we count the number of carbon atom from left side, 1 2, the substitute exists in carbon number 2, but on the other hand, if we count from right to left, 1 2 3, it means that the substitute present in the third carbon, which one is closer, left or right to the substitute? Left side is much better for the counting, so we count down it from left to right, 1 2 3 4 and 5. Okay, these are substitutes named as methyl group. Methyl. Students, there are two methyl groups which present on carbon number 2 and carbon number 3. So its name will be 2 3. Di stands for 2, dimethyl, and the total number of carbon atom in the parent molecule are 5. So its name is 2,3-dimethyl pentane. Let's see another example. We have to satisfy the valency of carbon atom. We have to select the longest chain. Okay, then we have to count down the numbering of carbon atom either from left or right. Where I have to count it, left or right? Tell me, students. Okay, good. 1 2 3 4 5. Now look at the substitute. It is present on the same carbon atom at carbon number 2, methyl. So its name will be 2 2-dimethyl, and the parent molecule is pentane because it has 5 carbon. 2,2-dimethyl pentane. Okay, let's see different other examples. Select the longest chain. These are substitutes, means branches, and the numbering of carbon atom 1 2 1 2, same pattern. Either you can count down from left side, either you can count down from the right side. It depends upon you. 2 3 and 4. 2 3 4. Trimethyl, and the parent molecule is pentane. Trimethyl pentane. Okay, let's see another example. Students, select the longest chain. It is correct. It is also correct. Okay, but you have to consider only one. Number the carbon atoms 1 2 3. There are two methyl groups which are present on the same carbon atom. 2,2-dimethyl. 1 2 3. The molecule which comprises of 3 carbon atom known as propane, because the parent molecule is propane. Why we call it propane? Because there exists a single bond between the carbon atoms. single bond in carbon carbon atom. So that's why it's propane, means it belongs to alkanes. It also belongs to alkanes. It also belongs to alkanes. Okay, students, enough. Let's go to another work. Electron, cross and dot structure. It is also known as Lewis dot and cross formula. Lewis dot and cross structure. How we have to write down it? For example, it's methane. Carbon has 4 valency, and if we have 4 hydrogen atoms, you have to mention the valence shell of hydrogen atom with cross and the valence electrons mentioned by dots of carbon atom. It means that one element, the valence electron of one element mentioned by dots and the valence electron of the other element mentioned by cross. So that's why it's known as dot and cross formula. It's also known as Lewis formula. Okay, look another example. It is known as ethane. Ethane, because it consists of 2 carbon atoms. Okay, clear it? Similarly, so on. You have to follow the same rule for propane, butane, pentane, hexane, heptane, or any other molecule, not only organic but also inorganic ionic compound, or for example ammonia, sulfuric acid, or any other molecule related to hydrocarbons as well as inorganic compound. Okay, let's move to another topic which is related to preparation of alkanes. Students, now you have to understand the preparation of alkanes, how you can prepare it in the laboratory or as well as in the manufacturing lab industries. Okay, we prepared them because these are very useful. They provide us very useful products. Okay, let's see preparation of alkanes. The first method for the preparation of alkane is cracking. What is meant by cracking? Cracking means splitting. Splitting the higher hydrocarbons having high molecular weight into smaller hydrocarbons which are required by using heat as well as catalyst. Such reactions required heat or temperature as well as catalyst. Okay, once again listen to me. What is cracking? The splitting of higher organic compounds having high molecular weight into smaller hydrocarbons which are required in the presence of temperature as well as catalyst. Next, see fractional distillation. It's the example of cracking. Fractional distillation of petroleum. Everyone knows about it, fractional distillation. What is meant by fractional distillation? Fractional distillation means the separation of organic molecule on the basis of their boiling points. The separation of the hydrocarbons or organic molecules on the basis of the boiling points. Those hydrocarbons escapes out or volatile easily, having low molecular weight, because they have very weak intermolecular forces. They have London dispersion forces. But those molecules which are larger in size, having high molecular weight, they lie besides or in the bottom of the cabinet. Okay, fractional distillation, the separation technique in which you distribute or separate the organic compound on the basis of their molecular size or boiling range or their carbon atom. For example, the crude oil that we obtain from the earth, it has kerosene oil, it has gasoline, it has diesel oil. Okay, different other examples, but the rest of the compound is asphalt as residue, which is known as naphtha. What is naphtha? Naphtha is the mixture of hydrocarbons which consist of natural gas, methane gas, petroleum fractions, tar, and many other fluids, blackish material, we have to pass naphtha into fractional distillation so that we might be able to get different useful products. And this technique is known as fractional distillation. When we provide heat to naphtha in the presence of a catalyst, zeolite is a catalyst, and you know that. What is the function of catalyst? Catalyst is any substance which can increase the rate of reaction without being used up. Any substance which can speed up the rate of reaction without being used at. You can get catalyst as it is. It just speed up the chemical reaction. It doesn't being used in the chemical reaction. Okay, clear it? Okay, naphtha, when we provide heat in the presence of a catalyst, zeolite is a catalyst. Okay, naphtha splits up into alkanes or different alkenes. Clear it? Okay, the second process for the, look at it, it is our product that we have to required alkanes, because we are discussing about the preparation of alkanes and we have prepared it. The second reaction, reduction of alkene and alkynes. Reduction of alkenes and alkynes. Look, reduction, what is meant by reduction? The addition of hydrogen, the addition of the addition of electron or the removal of oxygen is known as reduction. It is against the oxidation. Okay, this is an addition reaction, and it is also known as hydrogenation. The reaction is also known as addition reaction. Why it is known as addition reaction? Because in this reaction we add molecule into hydrocarbons. For example, if we are going to add hydrogen in the hydrocarbon, it is known as hydrogenation. If we add oxygen, it is known as oxidation. If we have to add halogen, it is known as halogenation. Okay, if we have to provide carbon dioxide, it will be known as carboxylation. And if we have to remove hydrogen, it will be known as dehydrogenation. Okay, if we have to remove halogen, it will be known as dehalogenation. D stands for removal. Okay, so we have to add hydrogen in ethene molecule. One hydrogen will adhere with that carbon and the second molecule will here. By breaking the pi bond, there are two bonds exist. That is pi bond and that is sigma bond. Pi bond. When one pi bond will break, when one pi bond will break, two sigma bonds will form. Two sigma bond will form. When one pi bond will break, two sigma bond will form. In the presence of nickel catalyst and 200 degrees centigrade temperature, that reaction also known as hydrogenation or addition reaction. In exams, the examiner will ask, define hydrogenation, also give one example. You have to put that example. Okay, ethane, one bond will break and one hydrogen lie with that carbon and the second hydrogen atom will attach with that carbon. In this way, it will form CH3, ethane molecule. Ethane, it was ethene and ethene convert into ethane. Second example, ethine, it is also known as acetylene. Ethine. When we add hydrogen in ethine, in the presence of catalyst, it converts into ethane, but it doesn't convert into directly. First, ethine convert into ethene, then ethene convert into ethane. Remember about it. And the third process, reduction of alkyl halide. What is meant by reduction? Reduction means addition of hydrogen. Of alkyl halide. Alkyl. The word alkyl gain from alkane. When we remove hydrogen, alkanes convert into alkyl. Look at its example. It's methane molecule. When we remove one hydrogen atom, it becomes a methyl. It was methane. The parent molecule is methane and the daughter molecule is methyl. Okay, methyl is produced from methane. So, in the presence of zinc, dust or hydrochloric acid, when we react zinc with hydrochloric acid, zinc chloride is produced as well as nascent hydrogen gas is produced. This nascent hydrogen gas we required in this process. It is known as methyl chloride. Methyl chloride. It reacts with zinc in the presence of HCl. This hydrogen is attached with that carbon and this chlorine removed and this attached with zinc because it has the affinity with zinc atom and it will form into zinc chloride. Okay, it converts into zinc chloride and the product is known as alkanes. CH3 and hydrogen, what is the name of that product? Basically it is methane. Either you are familiar with it or not. Tell me students, either you are familiar with methane or not. Methane is the parent molecule of alkanes. Clear it? Okay, see you tomorrow.